Before we continue, remember, if you find the material in this video too technical, please watch earlier videos where I cover basic electrical knowledge. Keep in mind that the first 28 videos are best understood if you follow their sequential order. Now, back to our video. These are Keystones and these are Newtorques. Keystones are going away, but they are still in the fleet, so you might find in your system is still being used. And these are the Newtorques. So now we'll talk about both of them.
Unfortunately, that's what they're called.
So this company, Keystone, there is a lot of them on the fleet still, but they are being phased out by the Newtorques.
Monday, always Sunday.
Okay, this Keystone, you have your capacitor, motor.
What is the capacitor?
This
That's
is
just
capacitor.
like what we can do.
Oh, okay. So is it a DC motor?
No, AC motor.
Oh, AC motor. Okay, yeah, AC's motor
It needs a capacitor to...
for the kickstart.
Yep.
Okay.
Okay, these are your torque, limit torque switches,
Every one of
Okay.
them takes like
heater.
It's a heater.
Mm-hmm.
Okay.
Yep.
If we do all of them right now,
And
can't do
these are your cams. Oh, nice.
40
New
hours
cams.
of work in one day. There's only 24
Okay.
hours.
And these are the limit switches.
so-
Oh, I see. The cams are big.
So yeah, so we have
So they are all
Okay. This one is normally closed. Okay.
normally
Where
closed.
the where
And
the
as
wires are
soon as it
connected
gets
to.
connected,
Yep, it opens.
it opens.
Mhm. So when
And sometimes these things will offset themselves a little bit. So it has a set screw over here.
yeah, it will move the cam to whichever point you want it to go.
And he's gonna demonstrate right now. Now we're good to go. All right, so he's moving the set screw over here, and you can see that the cam is being moved. So that's how you will adjust it. That's okay.
But
If
there
in-
are times when
If in
you
case
don't
it-
have this accessibility right here.
yes.
So all you have to do is move it manually with a hand wheel. Give you a clear, clear shot of the.
Oh, okay. So you move the whole thing,
Mhm.
so you can easily
Yep.
get your screwdriver to
And
adjust
then,
it.
if you move the cam all the way to where you cannot move it anymore, you have to loosen up the entire cam assembly
How you do
from
that?
the set screw in between. Each of them has their own set screw.
Okay, so
Besides the,
yeah, so
the
that's the
screw,
center set
the
screw.
one screw.
Okay, that allows you to fully rotate the whole thing. And then this one over here is the set screw that allows you in position now when this thing is already set,
Yep.
just to relocate
Do
the cam.
fine adjustment. This where you do fine adjustments.
So fine adjustment, and this will be the
the
overall
coarse adjustment.
course adjustment. Okay,
Because when you loosen this up, it moves the whole cam.
the whole
around.
cam around. Okay, thank you.
No problem.
The signal that comes over here to 2 and 3, they come in from the associated SSRs. So if the valve is not working, it could be, well, obviously a
The
bad,
switch not
a bad
aligned
capacitor
properly.
if it's not doing anything, or well, a capacitor will disable the valve to work either way, open or close.
Yeah, yeah.
A switch, a bad switch will cause you to not be able to either open or close.
Yeah, it will
But
circuits.
also it could be the SSR that is
SR.
associated to either open or close.
Yep.
So we got a Newtorque valve over here. This one can be used as a PRB or BGD
CWCV.
and sometimes as a CWC. Okay, so now typically when you are in the field, you only open this over here, and that it makes it really hard to work in. But because this is a working model, they were able to remove this whole lever so that they could actually do all the screws, and therefore I'm going to be able to show you the whole inside of it. Okay, so to begin with, I'm going to make sure that I'm going to point out to this special tool. This special tool is what is required to be able to adjust the cams. The location of the cams, okay, so those are the cams right there, okay? So behind is where the actual switches are at, and the top two are for white is open, black is closed. And if you will, they are the limit switches. The bottom two are for indication, okay, to let the system know that you are at 0% or 100% open. I'm gonna pull this out together so that so you can see a better view. Now, and you see there that they are the actual switches over there waiting to be engaged by the cams. Here are the cams, and if you see, they got this hex type of on the nylon, either the black or the white, and that's what you adjust with your special tool. I'm gonna set it up like this, and when the system is in place, you are able to just get it, and this is where the special tool comes in to be able to adjust this. Now, remember that if I'm adjusting the top white one, that's the only one that's going to be rotating, and the other ones will be stay not moving because I'm not moving them. Now, the whole thing is moved via this, the whole shaft, okay, which is taking the input over here from the whole thing when it's actually moving. Once again, these two are, this is the command stop open, command stop close, or not command, but like the maximum, the over travel. Okay, now we got over torque limit switches over here, and this should never get engaged unless somebody starts to try to open it too much by hand to either fully open or to fully close, and that's what they're there for. Here in positions 11, take that back, 12, 13, and 14, these wires, they go to a potentiometer. This potentiometer over here. So the potentiometer is to provide inputs when this valve is used as a BGD, or take that back, the PRB. When it's a BGD, this will actually be removed, okay, because the input for the BGD is actually going to come in from the proximity switch. The potentiometer, as you already know, well, it's going to have one common, and then, you know, one max and one low, and that's what the 12 and 13 are, and 14 is the common. Safe to say that whenever you're referring to the valve, this is what's called the top, and then obviously this is your indication, and that's the bottom. To adjust it, obviously, you know, you're going to play with it manually, and if this one is being used as a PRD, this, like I said, 12 and 13 is what's going to be providing the input to the input and output circuit card to show on the screen the position or percentage of position of this valve.
It's directly connected to the chassis.
Okay, so the circuit card, one way to read some of the components, obviously, I mean, we got all these connections over here, 1 through 9, and that's what they are here. So I was just told that one of the common problems with the circuit card is that it grounds. And the way how you do that to read it is you simply take a multimeter, put it into one of the test points, and then to ground with the ohms, and it should be open. But if you read 0, then that means the circuit card just grounded. So at that point on, now you know you gotta replace it. So this part over here, I remove it, but it's always supposed to be closed, and that's how you do most of your adjustments, okay? The fine adjustments is done with a special tool, but what is called a coarse adjustment, that's when you remove the whole thing, and now you can just rotate the whole thing to adjust it. But then once you do that, you're gonna have to still do fine adjustments.
And one thing, you need to have something to hold on to this portion, because if you don't hold it steady and you move one of the cams, the whole shaft will move.
Okay.
And all the cams together with it, see?
Right. Okay. So you just gotta hold it.
Just have to be held steady.
Okay.
And then you do your adjustment with.
I cannot hold it. I gotta hold. Okay. But
I usually use a wrench.
But I get the point.
Yeah.
Okay.
Slide will take a fat screwdriver.
Oh yeah, a big screwdriver.
Fat screwdriver.
Something super fat over there just to hold it in place. Okay.
And also, when you put in this back, this slit has to ride with the pin attached to the shaft. So in this case, it's not properly aligned because we rotate the cam assembly shaft. So just move it manually until it sits there.
Ah.
Just like that.
Okay. And then careful not to break because the
Yeah.
bottom part is metal and the top part is plastic.
Mm-hmm. They can easily get sheared off the plastic part.
Okay. Is there a way to adjust the potentiometer or that one? No, that one is just set.
Yeah, there is. There's a set screw. Good enough where the set screw becomes
to see the
visible.
set screw or the potential. I see it. It's coming in. The set screw is all the way there. See all the way hidden. Okay, so we have to rotate it so that we can actually get to it, so that we
It's
can
enough
actually.
for you to get good access to the set screw.
Okay, and we're talking about the adjustment of the potentiometer. If you ever need to do that, I prefer not to because that one is very sensitive. Remember, that's the one that goes from 0, meaning closed, to 100% being open, and anywhere in between is determines the position of that valve.
For this kind of actuator, if it calls for a potentiometer adjustment, you have to pull the cam assembly out.
Ah, okay. That's the only way.
Because then when you loosen this up, the set screw, then you have to manipulate the potentiometer while someone's keeping an eye on the microprocessor.
On the computer. Okay.
And only then you can they'll tell you, all right, you're 0 now. Okay, you stop it right there and mesh the gears together. You tighten up the set screw, and then put it back in.
on. Okay. So let's talk about the cams again. So the top is open, wide, that's closed. So these are limits. If for some reason, let's say you're trying to open your valve, but it only stops at 70%, that's because probably this guy is getting engaged and therefore not letting you open it more. This is the stop for, so this is the stop for open, this is the stop for close. Now, for open, and this is the indication for close. Okay, this is what you will be like should match up to be at 0 and 100%. However, the potentiometer, okay, should be aligned in a way that when the valve is closed, so when the black ones are engaged, the potentiometer should be reading pretty much 0, or wired in a way that it gives you in the microprocessor 0, and when the white ones are engaged, then the this one should be at 100%, or read 100% on the this display. And here is a visual, so you can see how the cams work. So here we got another valve, and it's just the same as the one before. As I got a better chance to inspect it, I did remove the part over here on the top, but down here, down at the bottom, there is a potentiometer, okay, that is just laying flat, and I'm just trying to focus over there. And the potentiometer really is controlled by this shaft. This shaft rotates. As this little lever goes up and down, it causes this plastic thing to rotate one way or the other ones. As it rotates the potentiometer that is laying down at the bottom with this shaft up, secured by this set screw over here, and that's how the potentiometer changes. Now, hey, so this is the piece that I was telling you about. Here is the potentiometer. And the way how it really works is pretty simple. So as you see, it will have a movement. Pay attention to this part over here, and you see that as the feedback rod, or I'm talking about this rod over here, when it goes up and down, which this one attaches to, that's how it actually gives control to the potentiometer. Also, you can see it here on the actual set screw, and that's how the system knows whether the valve is open or closed based on the feedback of this rod. So before I finish, let me talk about a quick summary of what all of this is. So on this part over here, we got a motor. It's just a single-phase AC motor. That's why it needs a split-phase capacitor. And down here, we got 3 micro switches. There's one all the way there, one over here, which are activated by this hydraulic device, which I'm not sure exactly what does it do. And I say hydraulic because this over here is a hydraulic pump. So this is a mini hydraulic system. When the motor rotates one way, so one becomes output, the other one becomes input, and they switch based on the motor rotation. And also, if you see over here, it comes into this manual bypass or way to activate the valve, because you can either open the valve manually or electrically via the pump. So to make sure that things work properly in the electrical side of the house, first of all, this cable over here is always powered, is number 2, and then these are the conditional. One of them is command open, the other one is command close. So whenever you get 110 across those two, the motor will rotate one direction, and when you get 110 in the other two, it will rotate the opposite direction. The feedback, as I said earlier, it comes down to these three over here through the potentiometer that we removed. And last thing I did forget to mention is this is the schematic for it. Let me refocus. And there we got the always power, which is 2, and then command open, command close, and these 3 over here are the potentiometer wires. This, if you're wondering what's at the bottom of it, can you lift it up? That's what it is, and this is the part that actually connects to the stem of the valve.
I had a real opportunity to go to a carrier, and here they got a 350-ton Newtorque AC compressor. But everything that I taught you already, you will be able to use that same knowledge. You still got your 5 pressure transducers. You still got JB2 and JB1. And if you look around, your PRV and your BGV valves, the condenser water control valve is a little bit different. Now, the condenser and the chiller are much bigger, they are separated, but they still have these valves over here, which will be your high gas bypass valves. Now, I look around and I see all these sensors. They have to go to all the corners, just like in the other one, and in fact they do. So those are your thermistors. If I continue going around all the way here, we got a variable proximity switch sensor all the way there. On the inside is absolutely the same. We still got our SSRs, our bleed-through capacitors, and obviously the same circuit cards.